Hi guys, we're just going live now. I hope you can hear me clearly. I think we posted the questions on FB. That should be, you should be able to access it. You should be able to try out the question. You should be able to see what the logical reasoning puzzle is all about. I'm going to share the screen in a short while. This is a very nice, wonderful, tough puzzle. And so give it a full-fledged go. I'm going to start speaking about the puzzle itself only after say 6-7 more minutes. So this is going to be this is a properly challenging, old-fashioned Venn diagram, fabulous question. And so give it a full-fledged go. Give it a complete try. In the meanwhile, if you have some queries, questions, do ping us on YouTube chat. But I'm going to start solving only after 5 more minutes. And so this takes time. I want you to draw the Venn diagram, think about what we are saying, do the maximum, minimum part, agonize over numbers, see why something might work, why it might not work, complete the grid, and all kinds of good stuff. So I'm not going to rush into this because the problem is classic, old-fashioned, wonderful, and tough. And so please do give it a full-fledged go. Try that question. I'm going to share that screen in a short while so that you can see the screen here as well. And then we'll take it from there. I hope you can all see the screen here. I'm not able to access the screen. I cannot see the YouTube channel and this at the same time. So I hope you can all see the screen. This is K and K. I'm going to read this puzzle ever so slowly. Once upon a time, there lived an artist named K in an interesting industry called K. And artist K gave many performances and became so popular that people started dissecting his role in the industry and history. Suckers. Turns out K started his career making commercial art, or broadly crap that sells. Soon he became very good at a number of things and became very keen to create wonderful art that would stand the test of time, like this question. And so he started venturing into stuff that came to be termed as hit or miss projects, which is very good. An artist should experiment, so should teachers. And so should dive into the deep sea and then see what is happening. And so that's what we believe in, at least. Somewhere along the line, K acquired a set of skills across the spectrum. So he became very good at A, B, C, D, E, F, and G, and was keen to highlight these extensively. So showcase what he was all about. And here came what would be called the vanity projects. And so he forgot the commercial aspect. Or he kept the commercial aspect in mind as well. But beyond the commercial aspect or the history aspect, there was the vanity aspect as well. And probably the natural progression of all artists. I don't know. Just as luck would have it, a great many of the projects fall into more than one category. Right? And that gets the mathematicians into it. The sweet, wonderful projects that fall into all 3 categories. This is your classic A intersection B intersection C in our Venn diagram jargon, are called bingos, right? BINGOS. Note that all projects K worked on could be categorized into at least one of the 3 classifications provided. So there is nothing that he worked on was none of the 3. And so that is an important point to keep in mind. Anyway, to cut a long story short, K worked on a total of 112 projects. So he worked on 112 totally, 78 of whom were commercial projects, 69 of whom were hit or miss ventures, and a staggering 84 were vanity projects. Now on to the question. So a long story, but very few data points. We've not been given too many numbers. We've been given very few numbers, only 4 numbers. So the story is very broad, but the number of numbers minuscule. So think about this. Think about what could sit underlying this after seeing the questions as well. What is the minimum number of bingo projects K could have worked on? What is the maximum number of bingo projects K could have worked on? If it is known that K worked on 24 bingo projects, what is the maximum number of projects that could have been crap that sells projects and vanity projects, otherwise known as stinkers? Who's interested in that? Commercial vanity projects, whoever likes that. If it is known that K worked on 40 bingo projects, that's amazing. What is the minimum number of projects that could have been crap that sells and hit or miss projects, otherwise known as good stuff? So he's venturing out, taking a risk, and it's commercial. So what is there not to like? That's what we're looking at here. So spend some time. This is not that easy a question. So give it a go. I'm not going to jump and say more than this. I'm going to jump to the solving part, the solution part in about 2-3 minutes. But keep plugging away. These are wonderful questions. All 4 of them are very good questions, especially the first 2. I'm going to do the first 2 in a freakishly methodical, iterative, step-by-step process, and then see if there is a genius, sweet method. And I'm staying away from that word shortcut because I hate that word. So if whatever we do, we'll not find a workaround. We'll work within the framework and try to figure stuff out rather than work around stuff. Right? So there's no shortcut here. I'm going to run through this whole thing. There are 3 sets broadly: stuff that sells, commercial stuff, stuff that is good, risky stuff, stuff made for showcasing something, vanity stuff. And so commercial stuff is 78, risky stuff is 69, vanity stuff is 84. But they're not independent. There is a certain amount of overlap across these 3. Total is 112. What we have been told very clearly is there is nothing outside of these 3. It's not one fabulous, non-risky, non-project stuff that is outside of these 3. So all 112 have got to be classified as classified under one or more of these 3 categories. And so that's the theme we are working under here. So fabulous question, fabulous outline, because there's a big story, but a long story short, there are only 4 numbers at the end of it. There are only 4 questions at the end of it. And so I've said this stuff quite a number of times. So those of you who have just marked the top of your head answers, work that. Make sure that your top of the head answers match. Fill the entire grid with your top of the head answers, and then we will proceed from there. Right. So wonderful. So I think we've had around about reasonably sufficient time. So we've had about, give or take, 12-13 minutes. So I'm going to plug ahead and think about outlining this. Because we're doing this online, there is no real way for you to put up your hand and say, hey, give me 2 more minutes. So live with it. So those of you who are still working on it and you're very close to it, perhaps you can hit pause on the video and then try it out yourself. And all you need to do is jump back on. Also, the live session ceases to be live for 5-10 minutes. Nothing that's wrong. One of the beauties of working online is you have the chance of shutting up the teacher and saying, look, I need to spend the next 5-6 minutes doing this on my own. Please, let's not rush into this. So if you fall into just that category, there is an absolutely wonderful button called as pause on the YouTube screen. Stick that in. That way the buffering issues sometimes disappear. And then you try, and then start seeing the solution. And I've recommended this to a number of our students. One of the biggest reasons I'm a gigantic fan of online projects, online courses, is that you can set your pace. So if you want 4 more minutes to work on this, take that, grab that, hit pause, try this to your heart's content, heart's fill. Get the whole thing with as many iterations as you want, with the whole bells and whistles. Get that completely, then continue with it. And so you have the option of taking more time. If you don't rush and see the solution, because it's a kind of question that the more time you spend on, the more clarity you get on all of set theory. And so I'm going to give you a form-like approach somewhere down the way. But the form-like approach, learning from that is the least of what you can get from this product, from this question. And the first time I did a question like this, it took me a long time. I had no clue that there was a short form-like approach for it. And then once the form-like approach was given, then I could appreciate the form-like approach because it fit in with all the iterations that I had done. And so do as many iterations as possible to get this stuff right. I'm sorry to be a bore about this, but the pace setting part is something that you have to grab because it's online. And so even our online course, we fought tooth and nail at every stage to make sure the pace setting is with the student. It is frightfully modularized for precisely that reason. And so you hit pause when you want to. And so now I'm going to build on this. And we've seen this question. What is the minimum number of bingo projects K would have worked on? Super. Now I'm going to go on and try this. He worked on 112 projects totally. 78 were commercial. 69 were hit or miss, and 84 were vanity projects. We need to find the maximum and minimum values of A. For the first iteration, we're going to find the minimum value of A, and then we'll try to find the maximum value of A. And so this is what we've been outlined right here. So 78, 69, 84. I want to do this iteratively. How do we do this iteratively? What could be the minimum value for A? A could be 0. I love 0. And so great contribution from India as well. So the nationalistic brigade can be really thrilled about it. A could be 0. If A is 0 works, we're good. We can all go home and we've got 1 mark out of this exam, or +3, whatever we call it. So A cannot be less than 0. 0 works, we're home and try. Let's stick in 0. And so, and we don't know so many numbers. So let's put some numbers here. Let's put it 0, 0, 0. For the heck of it, life is simple. And then try this out. What does it mean? That means this is 78, this is 69, this is 84. Life is good. You stuck that in. And so the total should be 78 plus 69 plus 84. We add these three, 13 plus 8, 21, 1, 2, 10, 16 plus 7, 23. Sum of these three is 231. Unfortunately, we want the total to be 112. So what we know is that this doesn't work. This framework, this set of numbers doesn't work. I'm still not saying A equal to 0 does not work. A could still be 0 and we might have filled something else incorrectly. That might be possible. The total should be 112 and we get a wacky 231. And so we're out of the ballpark on this one. So let's see if we can simplify this. Right? This is way more, this 231 is way more than the 112 we have. This doesn't work. And so therefore, let's say that 0 is not what, 0 is what we're filling here. But we've assumed arbitrarily these three to be 0. And so maybe there's something for us to work on there. Maybe all three of them need not be 0. For the heck of it, let's say this number here, we put it as 5. Let's just see what happens. And so I'm having trouble with the PowerPoint. I know this, if this happens, my PowerPoint crashes. So we're going to live with this fun of me restarting this machine. So I'm going to screen sharing. I'm going to stop screen sharing. I'm going to go back to the YouTube thing, and then we're going to crash this and then come back to that. And so I'm going to close this. I'm going to crash my PowerPoint, and then we'll come back to that. Not such a big deal. We've seen worse problems than this. So we're going to Control Alt Del or Control Alt Escape. I'm going to crash PowerPoint and bring this back to you. This stuff happens. This is one of the reasons why people like Apple products. I'm not such a big fan myself, but there are people who really like Apple products because of this very reason. And so I'm going to ask you to bear with me till we get going on this one. This is wonderful stuff. For some reason I have to locate this file and then restart it. So, work with this. Come back to this. Now I'm going to go back to screen share. I'm sorry about this. Sorry that you had to look at my face and not the screen for so long. Apologies here. We get some blame, Microsoft gets to share it. And so let's continue with this. We were at this point where we said, look, not that number, one of these numbers is 5. The wrong number is 5 compared to this template. We'll stick this as 5. If you put this as 5, this goes to 64, this goes to 73. Does this work? Intuitively, you can see straight away that this doesn't work, but I'm going to still do the numbers. And so the total is now 73 plus 5 plus 64 plus 84. 73 plus 5 plus 64 plus 84. I'm going to add all of this. This is still out of whack. This is way more than 112. And so this is, we're out of the ballpark here. But see, one thing that we've done, this is still way more. But if you put 5 here, this number goes down by 5, this number goes down by 5. It's wonderful. The two numbers go down by 5. I've added only a 5, so the total comes down. When We had an out of whack total of 231, but we found a mechanism to reduce the total. Our total has got to be 112. So this 231 is out of the ballpark. So we want to reduce that. So what do we do now? What is this, the mechanism that we have found out now? We are saying, look, this number increasing reduces this and reduces the total. There's a dual impact. So one positive and two negatives. My total is going to shrink. My total has got to be only 112. It started at a staggering 231. So let me shrink it. What is the mechanism? I'll put this as x, y, and z in such a way that these three go to 0. And that should work. Game over. So I'll increase the intersections. My crap that sells only, heterogeneous only, vanity only will shrink. And my total will shrink. And that's what I'm looking for, because my total is out of whack at 231. I cannot afford to have 231. So now what do we do? Now we can do this algebraically. Life is good. We know that x plus y is 78. Y plus z is 84. X plus z is 69. Game over. Solve for this. Find x, y, and z. We are through home and dry. Or are we? Does this work? Can you solve these? If it were this easy, I wouldn't have whined so long and hard about this being a very tough question. Right? So this doesn't work. If we add 2x plus 2y plus 2z, we add these three, we get 231. That we know. So if we get x plus y plus z, this is an odd. 231 is an odd number. So x plus y plus z does not come out to be a nice, pleasant, fun-loving integer. And so that's an issue to start with. That cannot be there. We cannot say that 1.5 movies were of the category crap that sells unheterogeneous. That's not possible. We all know that. And so this 231 is not just an odd number. And x plus y plus z is 231 by 2. If you put it as 115 to 116, between these two, we can pick something and work with it. But this number is more than 112. It cannot be possible. Our x plus y plus z cannot be more than 112. There are only 112 projects K has worked on. And so if K has worked on only 112 projects, x plus y plus z has got to be less than or equal to 112. That much we know. And so what does this tell us? We put the intersection number to be 0 and filled everything else in what I would call as best case scenario, and we still go nowhere because we cannot find the overall number. That doesn't match. What does this tell us? This tells us that the intersection number cannot be 0. It has got to be at least 1. Now we plug in 1. This works. Brilliant. That means x plus y is 77. X plus z is 68. Y plus z is 83. If we put a 1 here, the total will fall by 3 outside plus 1 here, or the total should fall by 2. And so I'm going to go over this again. If you put x, if you put 1 here, then this will fall by 1, this will fall by 1, this will fall by 1. So x plus y plus z, 2 times x plus y plus z will fall down by 3. Or x plus y plus z in this case turns out to be 114. And we've had an extra 1 as well. So 114 plus 1 is 115. It's impossible. Even 114 is impossible. We know that. X plus y plus z cannot be more than 112. That's a starting step, but that's not an ending step, because it could still be 112 and be impossible. We know that it cannot be 112, more than 112. That much we know. But we cannot say any number 112 or lesser works. So that is something we still need to worry about. But right now we're saying if it is more than 112, check it, it's impossible. So 1 also does not work. What do? We jack it up to 2. So we add these 3. The total will fall by 3. From 228 it will become 225. We know that. 225 by 2 is still more than 112. Not possible. 2 doesn't work. Jack it up to 3. With 3 we get 2x plus 2y plus 2z is 222. X plus y plus z is 111. Wonderful. We finally got a number less than 112. Maybe we get jackpot. But hey, worry about this. We introduced a 3 here. X plus y plus z is 111. But added to this 3, we go to 114. Again, this is not possible. We have only 112 available with us. So 3 doesn't work. Remember, once you jack this up, that 3 gets added to x plus y plus z. So if your total has to be 112, 3 also doesn't work. Let's take it to 4. You take it to 4, the total drops to 219. 219 by 2 is 109 and a half. Even if you take it as 109, 109 plus 4 is 113. That ain't working for us either. Our total has to be 112 or lesser, because outside I can put some number and manage things. Right? So let's check it up to 5. If you check it up to 5, 2x plus 2y plus 2z is 216. X plus y plus z is 108. That works. These three add up to 108. That is wonderful. But then plus this 5, we're up to 113. That doesn't work. So we've got 113 sitting there as a total number. No. Close, but no cigar. Let's take it up to 6. We take it up to 6, and these three add up to 213. They add up to 213. 2x plus 2y plus 2z. X plus y plus z is at least 106. More than 106. Plus 6 will take us to a number more than 112. So x plus y plus z, even after fudging, won't work. 6 also doesn't work. Let's try 7. We put 7 there. 2x plus 2y plus 2z is 210. X plus y plus z is 105. Plus the 7 is 112. Looks like we have a winner. And if you put this number as 7, then we are going somewhere. X plus y plus z is 105. Including this is 112, a total number matches. But let's still fill all the numbers. X plus y is 71. All three put together is 105. Or z, the remaining part is 34. X plus z is 62. Or y, the remaining part is 43. Y plus z is 77. Or x, the remaining part is 28. Or we've got a 28 here, a 43 here, and a 34 here. These three being 0. Let's do a very quick sweet check on all the possibilities here. 28 plus 7 plus 43, that is 78. This works. 28 plus 7, 35 plus 34, 69. This works. 43 plus 7, 50 plus 34, 84. This works. Adding all four, this is 84 plus 28, 112. That works. All conditions satisfied. We're sitting at 112 totally. 78, 69, 84 in those three gaps, and 7 in this bingo basket. Absolutely fabulous. We are good to go. And so 7 in the middle basket, and we are completely fine. And so 7 is the minimum number possible. And so it's a fabulous question. So I'm going to continue and then go to the next part. What is the maximum number of bingo projects they could have worked on? And so same, I want to maximize this. What am I going to put there? Think about this. We want to maximize this number. What is the maximum default value you can think of right now? So we know that A cannot be 112. We know that this is 78. You know what? There's a 178 sitting here somewhere, 169 and 184. We know we not get to their answer straight away, but I know we have a good starting point. A could be 69. Let's plug A in as 69 and then see where we go. Maybe it will work. If 69 works, we know we are true because it cannot be more than 69. So let's plug in 69 and then work from there. So 69, if this is 69, then automatically these three go to 0. Wonderful. This is 69, the other three have to go to 0. So we're good. These three numbers we automatically fill. Now, if we fill a number here, then these two get filled automatically. That we know. So if you put this as 1, 69 plus 1 is 70, so there should be 8 here, 70, there should be 14 here. And this is not done very scientifically, I'm just plugging in a number, nothing more than that. And so now, these three sets have the right number of elements. Now let's go back to the total. This adds up to 78, plus 14 takes us to 92, but we want the total to be 112. This doesn't work. This setup doesn't work. What can we do? Instead of 1, we could make it 2. If we made it 2, this will go to 13, this will go to 7. My total will shrink further. I increase this intersection, both of these fall, and my total will fall. I don't want my total to fall. I want my total to be 112. I'm stuck at 92. I want my total to increase. How do we do that? I don't reduce it, increase this, I reduce this, I take it to 0. This goes to 9. This goes to 15. And that is something that we can work with. This is possible. This is probably the best case scenario for getting the total as close as possible to 112 under the circumstances that we have. And so remember this. So if you put this as 69, and this could be 9, this could be 15. That means the total is 78 plus 15, which is 93. Again, once again, brilliant. We got this far, close. No cigar. They're not going anywhere. We cannot afford to have only 93. We need to account for 112 projects. So RFK, whoever he is not a genius who has got 69 bingo projects with this kind of profile. And so that doesn't work. No. We have done this so far. Now I don't want to do this iteratively, go to 68, 67, 66 and all that. That doesn't work. We got the hang of this thing. We know that if we take this and then time these three numbers, then I can get the total higher up. And so very methodically, if we time those three intersection numbers, then the total can go higher up. Our total is abysmally low, so I'm going to work on that. What do we do? So we put this as some x. Simply 69 minus x, 84 minus x, 78 minus x. What does the total become? Total becomes 78 plus 69 plus 84. We've done that many times. 239 minus 3x plus x. 231 minus 2x. That is what the total has become. And the total is 231 minus 2x. What are the best case scenario? What do we want this 231 minus 2x to be? What are we looking for here? This should be equal to 112. A home and dry. We put this as 231 minus 2x equal to 112. Very good. So, but if you do that, then you get 2x equals 119. Or x is 59.5. You've already been through this loop. You have an odd number for 2x. X does not work. We cannot afford to have a 59 and a half. So that means anything more than 59 and a half doesn't work. 60 will not work. 59 could. Let's put 59 in there in the middle. And then we'll say, wait, what goes there? We put a 59 here. And we need to accommodate that 1 somewhere. It's got an odd number. We put this as 1. This takes it to 60. This is 18. 60, 69, 25. So all the totals add up. This adds up to 78. This adds up to 69. This adds up to 84. The total overall, 84 plus 1, 85 plus 27, 104. This works brilliantly. It's a fabulous question. Predominantly because this question, we've been here only 4 numbers. It's a gigantic story behind it, but only 4 numbers. And so remember that, only 4 numbers being given here. And then we work with this big story, big hoopla. And then we asked to maximize and minimize. The best questions in set theory kind of like that are the ones where you're asked to maximize and minimize. So because there are hypotheticals thrown. What would life be without hypotheticals? I can imagine that I'm the Prime Minister. And so hypothetically, that should work. It'll be brilliant for the country, let me tell you. And so anyway, so this is the long, elaborate, iterative, fabulous, old-fashioned method of doing it. And so you guys are all running on short attention spans. You won't have time for this iterative method of the 20th century. As much as I can try myself for saying that's the best way to go about it, but I know that's not going to fly. So somewhere along the way, somebody is going to say, what is a brilliant method of doing this? What is the shortcut of doing this? Where can I do this really quickly in 2 minutes? And I'll be damned if we don't get into that market. Actually, we don't. But why should I not say it, given that I am going to get into that market? Right? Super. How do we go about this? We have set 1, set 2, set 3. We all know this fabulous formula. A union B union C is A plus B plus C minus A intersection B minus B intersection C minus C intersection A plus A intersection B intersection C. So, all of these I'm talking about cardinal numbers. You cannot add and subtract sets. And I'm talking about the number of elements in that set. So why do we do this? We add set A. This area gets double counted. And this, if you add A, B, and C, these areas get double counted. And this particular wonderful area gets triple counted. So to remove the double count, we subtract these. But when we subtract, the whole thing comes out. And because the whole thing comes out, this thing, which is A intersection B intersection C, is added thrice and subtracted thrice. So we add it back once. That's what we're doing here. Right? So there's another way of thinking about the same formula. We call this as A. I'm going to call this as x1, x2, and x3. Say A union B union C is A plus B plus C. When we add these three, x1, x2, x3 get double counted. Let me subtract that. And A gets triple counted. So minus 2A. Fabulous. We're good so far. Wonderful. So what do we do here? We know in our question, this is 112. This is 231. This x1 plus x2 plus x3, I'm going to call that as x minus 2A. So wonderful so far. So I hope all of you are with me this far. This gives us that x plus 2A is 231 minus 112, which is 190. Now, we want to find the maximum and minimum values of x, so of A. That's what we're looking for, not x, A. And so, how do we go about doing this? If A has to be minimum, x has to be maximum. If x has to be minimum, A has to be maximum. That much we know. We want to maximize and minimize A. And so, x plus 2A is 119. If you put A as 0, then this doesn't work, because x would then have to be 119. We know that is not possible. So if you put A as 1, x, if A equal to 1, then x equal to 117. That doesn't work either. If A is 2, x is 115. That doesn't work either. A is 3, x is 113. That doesn't work either. A is 4, x is 111. It looks like it could work, but then the total goes to 115. That doesn't work either. If A is 5, x is 109, total is 114, it doesn't work. A is 6, x is 107, total is 113, it doesn't work. A is 7, that means x is 2A is 14. Sorry, I made a mistake somewhere here. And A is 4, x is 111. A is 5, x is 109. 107, and this is 6. This is 14, this is 105. A plus x is 112. This works. This is how we went about kind of figuring out what was the minimum value of A. This equation is fabulous for all these kind of maximum minimum questions. If you given this question in the exam, you can rush to this. Then you can do this very algebraically. You're saying, okay, B1, x works, does not work. Simplify, then you're through. What is the other way of flipping this? What is the value for A to be maximum? X should be minimum. Put x as 0. If you put x as 0, then A should be 59.5. That doesn't work. Put A as 59. If you put A as 59, x should be 1. That is good. X is 1, A is 59, gives us the maximum possible value for A. And A is 7, x is 105, gives us the minimum possible value for A. And very, very vital to get to this equation, x plus 2A equals 190. That is the frightfully powerful bazooka of a method where you just plug in some algebra. So what we are doing here is A plus B plus C. We add all three sets. So the ones that are common to only two of the three sets, they get double counted. The elements that are common to all three sets, they get triple counted. So subtract everything that appears in only two of the three and subtract everything that appears in all three twice over. It's the same formula. It's the same formula called slightly differently. The idea is the same. A union B union C is A plus B plus C minus A intersection B minus B intersection C minus C intersection A plus A intersection B intersection C. Or if we just rejig things a little bit, we get to this. So x plus 2A is 119. From there, it's just a couple of short steps to finding the least value of A and the maximum value of A. The maximum value of A is just cakewalk, plug in x as 0, you're done. The least value of A, plug in A as 0, find x. It sometimes doesn't work out. So keep jacking up A. The constraint we are working up here is x plus 2A is 119 under the condition that x plus A is less than or equal to 112. We can take the outside part to 0, but x plus A cannot be more than 113. So x plus 2A is 119. under the condition that x plus a is less than or equal to 112. You can solve this as x plus a equal to 112, x plus 2a equal to 119, and find a equal to 7. But where is the joint that? So we will do this part still iteratively so that we have a sense on how x and a behave, but we'll get here algebraically. And so there is absolutely no point doing this algebraically without doing it iteratively. So go through the whole process iteratively, simplify that, see the whole damn thing, then come back to this method, then go back to the iterative method and then think to yourself, oh, this is what is happening here. The iterative method sets up the algebraic method. So don't bypass the iterative method. For the love of God, go through the iterative method, definitely, for sure. And so with this, we're done with the tougher 2 questions, the stage setting, difficult 2 questions. I'm just going to go take this further. We've done this whole process iteratively, then algebraically. I'm going to go to the 3rd question. It is known that K worked on 24 bingo projects. What is the maximum number of projects that have been cracked that sells projects and vanity projects, otherwise known as stinkers? So commercial, immodest projects. And so for vanity, stinkers, and so their name is appropriate. So what do we got here? We know that x is 24. So this number is 24. The x number is 24. This should be 24. So crap that sells and vanity projects, which is effectively this sliver. Pardon my diagram, not that good with art. So this is 24 and this is b. We want to maximize b plus 24. In other words, we want to maximize b, the part that is crap that sells and vanity, but not hit or miss. We want to take that as high as possible. We want to take b to the maximum value possible. And again, we're going to do this iteratively. If b is 24, we know x is 24. What is the highest value b can go to? That's what we're thinking about here. And so, if x is 24, we'll do step by step. We know that this whole thing is 78, this whole thing is 69, this whole thing is 84. All that we have done. And so, we know that this is 24. We want to take this as high as possible. We're looking to maximize b. And again, if you've not tried this out, you've come this far, you've seen the solution for the first 2 questions, hit pause, shut the teacher up, try this thing on your own, build this completely, and then we'll come back and you can continue watching the solution. This is going to be available on YouTube for a long time. So you can check out the solution 20 minutes later, 15 minutes later, but the value of checking out solution without trying stuff on your own is not that high. So keep that in mind. So now we've got 3 equations. We know that overall is 78. This overall is 69. This overall is 84. And we know everything put together is 112. So if you add this, and this, we'll get P plus Q plus R. We'll get 2A, 2B, 2C, and then 24 or X thrice over. And so if we think about that, then we can finally get A plus B plus C. We have already done this. A plus B plus C together, if you call that as some M, we know that M plus 2X is 231 minus 112, which is 119. And so therefore, you can directly find M. M is nothing but A plus B plus C. That is the other algebraic method, right? Again, I'm not outlining that algebraic method on this presentation because I don't want that to be handed on a platter. You sit and figure that out and then you try the question. But here I'm going to do it by the rigorous, roundabout, iterative, try till you die method. It's very vital to do that. At least I believe it is very vital to do that. Therefore, we'll continue with that. This tells us that M is, if you put X is 24, 2X is 48, M is 71. A plus B plus C is 71. So that's an interesting equation. What do we do from here? Can we want to maximize B? Can we just plug in A and C to be 0 and B to be 71? Let's try that out. B 71. This is 24. That doesn't work. 71 plus 24 is 95. That doesn't work. We cannot have that at 95 because the total available here is only 78. That doesn't work. Right? So So we know that 78 is a constraint. So let's chase that 78. So therefore, don't have 78 to be violated. What do I mean by that? This is 24. Make sure that this number can accommodate to 78, or stick this in as 54. And so therefore, this cannot be 0 anymore. So this is 54. And so well, let's build on this. This is 54. This is 24. We still have to accommodate C. We put in this is 0, because this total is 78, so this has to be 0. So we put this number as 54, so C should be 17. All three put together, A plus B plus C is 71. This is 54. This takes this to 0. So C should be 17. C is 17, 24, 54, 17. Life is good. This should work. And so if we put this as 17, let's come back and check whether all values work. This does not work either, because 24 plus 54 is 78. 78 plus 17, poof, 95. We have only 84 available here. So this 95 cannot work. 54 plus 24 plus 17 is 95. That does not work either. So 71 did not work. We jacked it down. 54 did not work because this 84 constraint is being violated. So let's see if we can tweak this even further. So now this 84 number is throwing a spanner in the works. So let's accommodate that. These two numbers added to 24 should be 84 or lesser, cannot be more than 84. And so let's work with that in mind. So B plus C added to 24 should take us to 84 or lesser, or B plus C can be 60 at the most, not more than that, or A has to be at least 11. And so that is one scenario where A plus B plus C is 71. These two cannot add up to more than 60. So it should be at least 11. Let's put that as 11. And if you take A higher, then B will have to fall. So we need to keep A as low as possible. The minimum possible value for A is 11. So let's put that as 11. So this is 11. That means B plus C is 60. Now we are back to our good old-fashioned table. This is 11. This is 24. This total is 78. What can be accommodated here? These two add up to 35. We need to take 43 here. That works. So B is 43. That can fill the entire grid. We can fill numbers here, 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 here. All conditions will be satisfied. If you add these three, 43 plus 24, 67, you can put in a, and the remaining 17 here. All the total will be 112. This is 78, 69, 84. All those add up. Or the maximum project that could have been C and V, that is Crack That Sells and Vanity project, is 24 plus 43, which is 67. And wonderful question, because we're doing it step by step, frightfully iteratively, and then building from there. And so the last and very final question in this. It is known that K worked on 40 bingo projects. K is a rock star now. He's nailing this stuff now. He's having 40 bingo projects. That's the stuff artists live for. It feeds my ego, it makes money, and is going to stay on forever. And so no one writers call bingo. And so how do we accommodate this? This number has to be 40. Now we want to find the minimum number of projects that have been Crack That Sells and hit or miss, otherwise known as good stuff. So we want the minimum possible value here. That's what we're looking for. So this has to be as low as possible. And so straight away, if we know this drill, we know that A plus B plus C plus 2 times 40 is 119, or A plus B plus C is 119 minus 80, which is 39. We want to minimize A, and we want to minimize A in the context that A plus B plus C is 39. If A plus B plus C is 39, our other constraints will fit the bill, and we know that. That is interesting, that is good, that is healthy. So A plus B plus C equal to 39. We want A to be as small as possible. We'll start with that wonderful small number, which is 0. We want to see if A can be 0. what happens if A were 0? What will happen in that scenario? That's what we're thinking about. If you put A as 0, so if you put this as 0, these two add up to 39. So 40 plus 39 is 79. This should be 5. I'm okay with that. I don't care about that. That could be 5. So B plus C is 39. This is 69 totally. Now let's see if you can put this as 29. And this is 10. So the A plus B plus C add up to 39. So Q can go to 0. 40 plus 10 is 50. P could be 28. If this works and does not violate any condition, we're good. We've got A as 0. It cannot be less than 0. If you get a solution possible with A equal to 0, we're good. The minimum cannot be less than 0. So we've got minimum at 0 for A. We're good, you're true. And so as it turns out, if you put this as 0, these three add up to 78, this works. These three add up to 69, this works. 40 plus 10, 50, 55, 84, this works. Total of all of these put together, 28 plus 10, 38 plus 40, 78 plus 29, that is 107 plus 512, that also works. All our conditions are satisfied. So K worked on 40 bingo projects. The minimum number of projects that have been crap that sells and hit or miss would have been 40. What we mean is this 40 is all that exists, and this goes to 0. And so we have a scenario where A could go to 0. We know that below 0 is not possible. We cannot have a scenario where A is less than 0. So if the minimum number of good stuff projects is 40, that is the 40 that is bingo. It cannot be less than 40. Bingo projects are the ones that come under the intersection of crap that sells and hit or miss, any which way. So outside of 0, that's the best possible scenario. The minimum we're looking for is 40. And so absolutely fabulous question. I'm going to stop sharing my screen and then revert to going back to the YouTube lecture to see where we stand on questions and queries and doubts and all that. And then we'll go up to the second set of questions. And so wonderful. So I'm going to type in the second question on Facebook. We have time. We only have 5 minutes to go. So I'm going to stop here. I'm going to answer a few questions and queries that you might have. So post the questions I have had. I did line up one more excellent question, which is a lot of fun as well. But this question takes an enormous amount of time. I'm not going to start off with the second. Second question is simpler than what we saw, and I did not want to compromise on the discussion for the second one. So I'm going to stop with that. We will have plenty more sessions. We'll definitely do one more session on logical reasoning, say a week from now or 2 weeks from now. In fact, sign me up for that. I'm going to do that second question, probably one more Venn diagram question a week from now. So we will discuss that and have a long discussion to see what are the different options there and how we can discuss that and all that. Any other questions you're there now? Shoot, this is a good time. I can now see the screen. I'm back on YouTube, so I hope you had a meaningful time approaching this question. I'm going to answer a few of the queries that have been posted. Anupul Srivastava says, why do we need to add 24 to it to get 67? Because we've been asked for A intersection B. A intersection B always includes A intersection B intersection C. A intersection B intersection C is a subset of A intersection B. Remember that. Anshuman Ray says, I couldn't join the session due to slow network speed. Would I be able to watch the entire video later? You will be. We're going to have a plan to transition the videos to the online course at some point of time in the future, but it's not going to happen anytime soon. So it is available now. I'll be available for the next few weeks, definitely. So should probably continue to watch it on YouTube. So it's not going to change. Not going to go out of YouTube. Rishu Bhatt has asked a question. 112 is 213 minus x minus 2a. Why minus 2a? I just see he says he's got it. So y minus 2a any which way. We're subtracting part that are there in exactly 2 of the 3 sets once, and stuff that are there on all 3 sets twice over. So the exactly 2 over the 3 gets added, gets double counted, so we subtracted once. Present in all 3, that gets triple counted, so we subtract twice. So a plus b plus c double count some stuff and triple count some stuff. So we manipulate that to remove the double count and triple count. That's what the original formula is. A union B union C being a plus b plus c minus a intersection b minus b intersection c minus c intersection a plus a intersection b intersection c is pretty much exactly about that. So removing the double count and removing the triple count. We do that in a couple of iterations, but this is what we did the iterative removing part and then did the normal part. So why not take BS? A session on data interpretation. We'll finish one more session on LR and then we'll come back to data interpretation. And so we've decided to do a bunch of sessions on DI and LR. We've done one DI and one LR so far. We'll do one more LR and then come back to DI. I don't see too many other questions on YouTube. I'm just browsing through the questions to see what else could work. This is a fabulous question, so I would still recommend that if you have not tried it, don't worry about seeing the solutions on YouTube. Give it a full-fledged go and then come back. So if you're midway, pause, try, and get back. Don't rush to see the solution. There's no joy in seeing the solution if you have not tried long and hard on this. And so remember that. That's about it. I'm going to sign off now on YouTube Live. I'll be around for the chat for a while longer. I'm going to be around on FB to answer any queries and questions. It's a fabulous set, as I mentioned. Extra point from someone who finds out and says, what could possibly be K in K? This is a local thing. I probably will give away the answer sooner or later. K in K. What could be K? What could be K? So K is indeed an artist, and K is an interesting industry. So let me give you a clue. K starts with K and rhymes with Hollywood. And K is a very popular leading performer in industry K. And so I'm not going to say more than that. He's a big star, and he's done a fabulous set of movies, and he's made a fabulous set of movies which have made a lot of money. But then, unfortunately, for better or worse, he's gone on to make a bunch of movies that can only be treated as vanity projects. For the love of God, and as a big fan of K, or erstwhile big fan of K, I hope he stays away from these vanity projects and gets on board and does a lot of wonderful movies which we can watch now and 25 years later. And so, to his credit, he's done a lot of brilliant movies, and just hopes he can shed these vanity projects, bin them once and for all, and then finds its place in history. Wonderful, guys. I'm signing off now. I had a lot of good fun, so we will definitely come back and have the remaining logical reasoning puzzle either next week or the subsequent week, either after doing one DA session or before that. Cheers.